The elements phosphorus and chlorine form a compound. Which of the following claims is most likely to be true? The bond between phosphorus and chlorine is metallic. The bond between phosphorus and chlorine is nonpolar covalent. The bond between phosphorus and chlorine is ionic. And then the bond between phosphorus and chlorine is polar covalent. Okay, so it seems like for all of these, we always just find the similarities and then we can pinpoint the differences. Now for A, B, C, and D, right, this is a multiple choice question, they're always talking about the bond. So we want to know the interaction between phosphorus and chlorine. Now, first off, we have to identify what is phosphorus, which is capital P, and what is chlorine, right? Now, this should be a refresher. We should know where these guys are on the periodic table. Phosphorus is a nonmetal. And chlorine also is a nonmetal. So we have two nonmetals interacting with each other in a type of bond. Now, since these are two nonmetals, it can't possibly be metallic. So this one is already out, right? And then I see nonpolar covalent, ionic, and polar covalent. Also, this can't be ionic because ionic generally, 95% of the time is when you have a metal and a nonmetal. It's not always the case, but that's the general trend. Here we have two nonmetals. Two nonmetals, and only two nonmetals, is never going to form an ionic bond. So that one's out. So now we're down to this idea where is it nonpolar covalent or it's polar covalent? Well, we know that it's covalent, which means that this is going to be sharing of electrons. It's a covalent bond, which means that the electrons between the bond are going to be shared. The dots here are going to be shared. But now, are they going to be polar or nonpolar? Well, if it's nonpolar, that means that there is no pull. There is no greediness of these electrons, which means that the electrons would be right smack in the middle between the two atoms. If this bond is classified as polar, PP, that means that there would be some type of pull or some type of greediness. And maybe phosphorus would be pulling the electrons closer to it, or chlorine would be pulling the electrons closer to it, but it would not be right smack in the middle. Now, there's a couple of ways to go about this question. The first thing is the general mnemonic of SNAP, S-N-A-P. If the atoms between your bond are symmetrical, aka if they are the same, that's when you would have no pull. You would have a non-polar bond. And maybe I'll just bring this a little bit out just so I could finish. So if those atoms are the same, generally you would have a nonpolar bond, no pull. But if you have different atoms across that bond, you would have some type of greediness and it would be polar. So you could always snap it out. So, since I have phosphorus and chlorine, one are different. These are asymmetrical. And by general definition, asymmetrical is always a polar covalent bond. So, by that, we could claim that the bond between phosphorus and chlorine is polar covalent. Also, what you can do, if you want, which I'll show you quickly, you could also go and check out the property that gives the polarity or gives the polarness or the pull, and that's electronegativity. We go and check our electronegativity differences between the two atoms, and then we just check it out. Here is my lovely electronegativity chart that I've made for you guys. All the electronegativity values are found below the atom. And it is safe to say, and maybe I'll do this in green, we did say that phosphorus was a nonmetal, and chlorine was also a nonmetal. The orange, in this case, is your nonmetal. So all the ones that are in orange are classified as nonmetals. Phosphorus is 2.1 and chlorine is 3.0. So the electronegativity of phosphorus is 2.1, chlorine is 3.0. Let's go back to the question and answer the electronegativity difference part of it. So we have phosphorus being 2.1 and chlorine being 3.0. There is totally a difference between these numbers. And if you wanted to find out the electronegativity difference, that means that you subtract these two. Your electronegativity difference should always be a positive value. So you just take the higher number and subtract it by the lower one. So 3 minus 2.1 is 0.9. If we're going by numbers and not snapping it out, just know that a polar bond is an electronegativity difference from 0.4 up until 1.8. And 0.9 fits the mold. So that's just another way to get to the same answer. The beauty of chemistry is there's tons of different ways to find out the correct answer. So I just gave you at least 2 here. All right, that's it. What'd you think? Thanks for hanging out, learning all about, polar, nonpolar, ionic, metallic. If you want more questions, head on over to glazersguide.com. The link is in the description below. We got tons more questions for your whole chemistry course, so check it out. All right? And, as I always say, for more practice and for more fun, guys, head on over to that website. I'll see you there, all right? I hope you guys have a great day. Talk to you soon. Bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.